All right, we've been working with bearing, and there are two different methods with which you can calculate bearing. So this is finishing up the first version where you always start at due north, and then you count from there going clockwise. Okay, so this example, radar stations A and B are on an east-west line 3.7 kilometers apart. So it's just going to sketch, okay, east-west line. So here's A and here's B and 3.7 kilometers. Station A detects a plane at C on a bearing of 61 degrees. So remember, you're going from north. Let's try again. Okay, and then so north 61 degrees would be an angle measure kind of like that. Okay, and so it sees this plane at C. Station B simultaneously detects the same plane on a bearing of 331 degrees. So now B is the origin, your starting point. And then if you're going 331 degrees, so north, this is 0 degrees for north. So 331, so here's 90 degrees, 180, and then 270 would be here, and 330, maybe something about like that. Okay, so 331 degrees. Okay, so they also see the plane. Well, I need to extend this a little bit. So here is our plane C. Okay. All right, find the distance from A to C. So we are looking for this side B. Okay, so it might not be obvious right now where we're going with this, but let's see what angle measures we can come up with, and then that will help us figure out how to find that length from A to C. Okay, so there's a couple of different things you know. So this is 100 or 331 degree angle, and you know that this far around is going to be 270 degrees. Okay, so if the total angle measure is 331, if I go 331 minus your 270, you get 61 degrees. So this angle right here is going to be a 61 degree angle. Okay. Well, then if you go over here to the left where station A is, again, you're going north to east. This is going to be a 90 degree angle. So if that's 61 degrees, then you have 29 degrees would be that angle at A. So then a 29 degree angle plus a 61 degree angle plus angle C. Okay, so you are going to figure out that this is a right triangle. So angle C is a right angle. Okay, you cannot assume that. So you do have to find enough information to give you a right triangle. Okay, but since we know it's a right triangle, we can do SOHCAHTOA. So I'm going to choose to go from angle A. So from angle A's perspective, your 3.7 is going to be your hypotenuse, and angle B is going to be, excuse me, the adjacent side. Okay, so adjacent and hypotenuse would be cosine. So cosine of angle A is adjacent over hypotenuse. So that's going to be 29 degrees. And then B over 3.7. Okay, so multiply B is going to equal 3.7 times your cosine of 29 degrees. And that gives you 3.24 kilometers for that distance. Okay, so before we move on to the next one, I wanted to spend a couple minutes maybe going back over this concept with this bearing. So let's kind of back up a little bit. And if we just say, what if I give you an example and say from point P to point Q is a bearing of 102 degrees. Okay, so what would a sketch of that look like? Okay, so from point P, you are starting at point P, so that's your origin. So here's P, you got your north, south, east, west. To Q is a bearing of 102 degrees. So remember, north is 0 degrees. So 102 degrees, here's 90 degrees. And so 102 would be about right here. Okay, so from P to Q is a bearing of 102 degrees. Okay, now what if we added a second piece to that and we said, okay, so now go from Q to S, and it has a bearing of 200 degrees. Okay, Q to S, bearing of 200 degrees. Okay, so now Q is your center, it's your origin. Okay, so if I'm going to do a bearing of 200 degrees, again, north is 0 degrees, 200. So 90, 180, 200. And then S, okay, so this is a 200 degree angle. And then S is down there. Okay, so that's just a little bit more, giving you another example with sketching out that bearing.